This is section 2.4, which is dividing and factoring polynomials, and is connected to the AP Precalculus standard 1.11, which is equivalent representations of a polynomial. So to start off with, we're going to do a quick review of how we factor different polynomials. So we have 3 different types, so I want to give you an overview of each of these. So if you look at part A, you'll notice that they all have an x in common. So the first thing I'd want to do is factor out an x, which is going to give me 4x squared plus 7x minus 2. And then we're not done unless what's inside can't be factored as well. So inside the parentheses, we have a quadratic. So this is where you can use factoring by grouping. You could use guess and check. You can use the area model. So I'm going to show you the area model because it's a useful tool if you're not sure what to do. So if I take this quadratic that's inside, I'm going to put the 4x squared in the first box, and I'm going to put the negative 2 in the diagonal box from it. Then I'm going to multiply those two together, and I get negative 8x squared. So we're looking for two numbers that multiply to negative 8x squared and add to my middle term of 7x. So that would have to be 8x and negative 1x. So I'm going to put that in each of the empty boxes. It doesn't matter which one goes where. And then I'm going to go each column and each row and figure out the greatest common factor. So if I look down the first column, 4x squared and negative 1x, they both have an x. 8x and negative 2 both have a 2. And then if I go to the first row, 4x squared and 8x, they have a 4 and an x. And negative 1x and negative 2 both have a negative 1. So that means that this would factor to x plus 2 and 4x minus 1. And remember, I didn't forget that that x is out front also. So that is my factored form of that quadratic, or that cubic. Okay, part B is another cubic, but this one has 4 terms. So if you notice that it has 4 terms, the way that I would try to factor it is by grouping. So I would try to group those first 2 terms and the second 2 terms. I'm going to change that to a plus and put the negative right there with the 4. So then I'm looking for what does the first parentheses have in common. So the x cubed and the 3x squared, they both have an x squared. So I'm going to factor that out. And then what do negative 4x and negative 12 both have in common? They both have a negative 4, which is going to leave me with x plus 3. Okay, so you'll notice that what's inside the parentheses is the same. And so that tells me that I did it right, and I can group the two together. So I can group the x squared and the minus 4. And then I'm multiplying that by x plus 3, which is the same, which is both of these come together into one parentheses. So then the last thing I can do here is x squared minus 4 is a difference of squares. So we need to recognize that, and we need to factor it further into x plus 2, x minus 2, and we still have the x plus 3. So that is my factored form for that cubic. So then the last one, we have x to the 4th minus 81. This is also a difference of squares. So recognizing that, we know we can factor this into x squared plus 9 and x squared minus 9. And then I can even go further because this is also a difference of squares. This one is not because it is a plus. So we can't factor a sum of squares and get real factors. So we're going to leave it as x squared plus 9, but we're going to turn the x squared minus 9 into x plus 3, x minus 3. So those should all be ways of factoring that you remember from Algebra 2. So this is just kind of a quick overview reminder of those. Okay, the next part is long division of polynomials. So we can long divide any 2 polynomials, but we can only synthetically divide if our divisor is a linear function. So on this case, we can see our divisor is a quadratic. So, and I'll label all of these too. So our first part, this is the dividend. This is our divisor. And our answer is going to be the quotient. So again, if the divisor is not linear, we have to do long division. Most people like synthetic division. That's the thing I'll show you next, because it's a little bit quicker, a little bit easier. But we have to recognize when each method is appropriate. Okay, so I'm going to set up my long division here. So here's my division symbol. I'm going to put my dividend underneath. And it is important that if I am missing a power of x, so I'm going down in degree each term, if I'm missing a power of x, like you'll notice I have x to the fourth, x to the third, I do not have an x squared. So I'm going to put 0x squared as a placeholder. I also do not have an x, so I'm going to put 0x as a placeholder, and then minus 3. And then same thing with my divisor. If I was missing any powers of x, I would put a placeholder there. Okay, so what I'm going to do is I'm going to look at the first term of each of these, and I'm going to say, what can I take x squared multiplied by to get 2x to the fourth? Well, that would be 2x squared. So I'm going to write that above my x term, and now I'm going to multiply. I'm going to take 2x squared times my x squared, and I get 2x to the fourth. Then I'm going to take 2x squared times my second term, my x, and I get 2x to the third. And then I'm going to take 2x squared times 1, and I get 2x squared. My next step is to subtract. So those first terms cancel. I have 1x cubed minus 2x cubed, which is negative 1x cubed. Then I have 0 minus 2, so that would be negative 2x squared. And I'm going to bring down my next term, which is 0x. Okay, now we do the whole process again. This time we're looking at x squared, and we're looking at negative 1x cubed. So we say x squared times what gives me negative 1x cubed, and that would be negative 1x. It's okay to also just write negative x. Negative 1x times x squared is negative 1x cubed. Negative 1x times x is negative 1x squared, and negative 1x times 1 is negative 1x. Now we're going to subtract. Be really careful on these about your negatives. So the most errors are going to come from just simple sign errors. So those first terms cancel. I have negative 2 minus a negative 1. So it's really negative 2 plus 1. So that would turn into negative 1x squared. And then 0 minus a negative 1 would be plus 1x. Then I'm going to bring down the negative 3. So then we start our last set here. We're going to take x squared and negative 1x squared, and we're going to say, what would I multiply by? Well, that would be negative 1. So negative 1 times x squared is negative 1x squared. Negative 1 times x is negative 1x. And negative 1 times 1 is negative 1. We subtract. Those first terms cancel. 1 minus negative 1 would be 2x. And negative 3 minus negative 1 would be minus 2. Now I know I'm done because I can't multiply x squared by anything to get it into 2x. So, and I also notice that everything is nice and lined up in my, above my dividend. So what I have right here, this is my remainder. And how we write our answer is we have our quotient up here. So this is our quotient. And we're going to put plus after the quotient. We're going to put our remainder, 2x minus 2, over our divisor, x squared plus x plus 1. So this whole thing is my answer. Okay, so now we're going to talk about the easier way. So again, synthetic division of polynomials is when the divisor is linear. So again, you notice here is our divisor. Our divisor is linear, so we can do synthetic division. So how we set up synthetic division, we are going to take the coefficients of the dividend. So I'm going to put that up here. Coefficients of the dividend. So again, here's my dividend. I have a 3, which comes from right here. I have a negative 2, which comes from right there. I'm missing an x. So remember, we have to have every value. So we have an x cubed, we have an x squared, we're missing an x. So I'm going to put a 0 for the x term, and then I have a -5. So those again came from right there. Okay, the number that goes outside of my synthetic division is what makes the divisor equal 0. So in this case, it's a 1. So I'm going to put a note here. What makes divisor equal 0? So x minus 1, the number that would make that equal 0 is 1. So now what we're going to do is we are going to always drop down our first term. So we drop down the 3. So now we are going to multiply our 3 by our k value, which is that number right there. So 3 times 1 is 3, and we're going to put it right here. Then we're going to add down. So we're always adding down, multiplying by k. So -2 plus 3 would be 1. So we put that right there. Now we multiply again. 1 times 1 is 1. Now we add. 0 plus 1 is 1. Now we multiply. 1 times 1 is 1. And then we add. -5 plus 1 is -4. I always like to draw a box around my final number because that reminds me that that is the remainder. So now what we have to do is we have to put our x values back in. So if I start with x to the third and I divide out an x, I'm going to have 1 power less. So this would be 3x squared plus 1x plus 1. And then we can put our remainder, -4, over our divisor, x minus 1. So it's important when we're doing synthetic division that we also remember we have to write the final answer. So just writing the numbers down here, that's not the final answer. It's a shortcut that allows us to divide quickly, but we still have to put our final answer. Okay, last thing is a couple theorems. So the factor theorem says that if the remainder is 0, the divisor is a factor. So basically, if you're doing synthetic division or long division and you get a remainder of 0, that means that whatever you're dividing by is a factor of that dividend. The remainder theorem, this says that the remainder of the dividend evaluated at that x value. So this is our example from the previous slide. So if we go back here, we got -4 as a remainder. So what the remainder theorem says is that if I evaluate this function at the value of my k value, so f of 1, so if I did 3 times, positive 1, 3 times 1 to the third minus 2 times 1 squared minus 5, I'm actually going to get -4 as my output. So doing synthetic division gives us a remainder that is the same as what we would get if we evaluated the function at that x value. Okay, so that is it for 2-4.